Now we're going to move on to solving logarithmic equations. Again, I have some steps here. Some of them are similar, some of them are different. Here's an example. We're going to solve for x in this logarithmic equation. How do I know it's a logarithmic equation? Well, it has the word log somewhere. ln counts as the word log, and it has an x inside of the logarithm. Okay. The first step is to get the equation into log base a of c equals b form, and we have that here. In this case, a is e, because log base e is natural log. And then c is what's inside the logarithm, equals, and then b in this case is 4. And so it's in the correct form. So now what we're going to do is we're going to make both sides of the equation exponents with a base of a. Well, what's a? Again, the base of this logarithm is e. So in this case, a is e. So we want to make this into an exponent and this into an exponent with a base of e. So that's basically what's going to e to the power of this and e to the power of this. That's what we're going for. So we're going to have e to the power of the natural log of 6 plus 7x equals e to the power of 4. So now the expressions on either side of the equal sign are now exponents with a base of e. Then what we're going to do is we're going to cancel the a to the power of log base a. In this case, that's e to the power of natural log, because natural log is log base e. So e to the power of log base e, we're going to cancel it and bring down what's inside the logarithm. So 6 plus 7x is equal to e to the 4th power. Now we're just going to solve for x. Subtract 6 from both sides. We have 7x is equal to e to the 4th power minus 6. Divide by 7 on both sides. And we have x is equal to e to the 4th power minus 6 over 7, which we can do in a calculator. So let's switch over to the calculator here. And we're going to do e to the power of 4, okay, and then divided by 7. I know what you're thinking, where's the minus 6? Well, I'm going to go back up and put it in. It's just sort of, this calculator is a little weird like that. And so look, now we have e to the 4th power minus 6 divided by 7. We hit execute and we get 6.943. We're going to round this 2 up to a 3 because of the 5. So 6.943. And so x equals 6.943. Okay, let's try another example. All right, look at this one. We've got log base 64 of x is equal to 2/3. So it's already in the log base a of c equals b form. Make both sides of the equation exponents with a base of a. So it's going to be 64 to the power of log base 64 of x equals 64 to the 2/3 power. And now we cancel the 64 to the power of log base 64, and all we have left is the x. Bring down the x. We have x is equal to 64 to the 2/3 power, which we can do in a calculator. So we can do 64 to the power of 2 divided by 3. Oops, that's 2 divided by 2, 2 divided by 3. And we get 16 as our answer. And so x is equal to 16. Okay, that was a pretty easy example. Let's do another one that's maybe a little more challenging. All right, here's another one. We have 7 log of x. This is log base 10 because it's just log of x, so it's log base 10. So 7 log of x is equal to 9. This is not in the correct form. We have an extra 7 here, so to get it into the correct form, we're going to divide by 7 on both sides and cancel the 7 over here. Now we have log base 10 of x is equal to 9 over 7. So now it's in the correct form. Now we're going to make both sides of the equation exponents. So the base of this logarithm is 10. So this is going to be 10 to the power of log of x is equal to 10 to the power of 9 over 7. We can cancel the 10 and the log, and we bring down the x, and we have x is equal to 10 to the power of 9 over 7. Maybe this wasn't that hard. So let's go ahead and type that in. And we'll type in 10 to the power of 9 over 7 equals 19.307. 19.307. So this is x is equal to 19.307. Okay? All right. Now let's try something a tiny bit more challenging. All right. So we've got 4 times the natural log of 3x minus 1 equals 17. So here's our log, here's our c, here's our equals, here's our b. We've got this 4 left over. So we're not quite in this form yet. Let's divide by 4 to cancel the 4. Divide by 4. We now have something a little easier. Natural log of 3x minus 1 is equal to 17 over 4. Now, we're going to make each one of these an exponent on the base of this logarithm, which is e. So we're going to do e to the power of the natural log of 3x minus 1 equals e to the power of 17 over 4. We're going to cancel the e in the natural log and bring down the 3x minus 1, and that's equal to e to the power of 17 over 4. Now we solve for x. Add 1 to both sides, and we get 3x equals e to the power of 17 over 4 plus 1. Divide by 3 on both sides, divide by 3, and we get x is equal to e to the power of 17 over 4 plus 1 over 3. We can put this into the calculator. All right, so we'll do e to the power of, let's put parentheses around it, 17 over 4, there we go. Then we're going to wind up dividing that by 3. We want 3 in the denominator, but let's go back up and we'll put our plus 1. Is that what it is, plus 1? Yeah, e to the 17 over 4 plus 1 over 3. And so that's what we have here. And then we just hit enter, and we get 23.702. So this is x is equal to 23.702. Okay? All right, let's try another example. All right, let's try this one. Again, we have something on the front of the logarithm, so we got to get rid of that. We're going to divide by 5, cancel, divide by 5. We have log base 7 of 11x minus 3 equals 13 over 5. Now we're going to take the base of 7 and we're going to make each of these an exponent. So we're going to have 7 to the power of log base 7 of 11x minus 3 equals 7 to the power of 13 over 5. We can now cancel the 7 to the power of log base 7, bring down the 11x minus 3 equals 7 to the power of 13 over 5. Okay. Now we're going to solve for x. We're going to add 3 to both sides. 3. We get 11x is equal to 7 to the power of 13 over 5 plus 3. Now we're going to divide by 11. Divided by 11. So we have x is equal to 7 to the power of 13 over 5 plus 3, and then all divided by 11. Okay? So let's see how we're going to put this into the calculator. I'm going to start by doing 7 divided by 11, and then I'll manipulate the numerator. I'll go up here, so I'll do 7 to the power of, what are we, 13 over 5? 13 divided by 5, and then we're supposed to do plus 3. Plus 3. So 7 to the power of 13 over 5 plus 3, then all divided by 11. If I hit execute, I get 14.59. 14.59. So x is equal to 14.59. Okay. All right, the next example is a little more challenging, but not too bad. Okay, so this one's a little, it's not like the other ones. So we got log base 2 of x plus log base 2 of x minus 14 equals 5. It is definitely not in this form, but we actually can make it in this form because we have a common base on the two logarithms and we have addition. So we can use one of the properties of logarithms to be able to combine these together into a single logarithm. So this will become log base 2 of, we have addition, so we're going to multiply the x times the x minus 14. So I'll have x times x minus 14 inside, All right, remember, we use the multiplication and addition property of logarithms, okay, to make it a single logarithm, equals 5. Now, we're going to make each one of these an exponent. See, make both sides of the equation exponents on a base of a. All right, and a in this case is 2. So we'll do 2 to the power of log base 2 of, I'm going to distribute this x here. I'm going to do x times x, that's x squared, and x times negative 14, that's minus 14x. So x squared minus 14x, okay, equals 2 to the power of 5. Well, 2 to the power of 5, that equals 32, okay? So now we're going to cancel the 2 to the power of log base 2. We're going to cancel that, and we're going to bring this down. So we have x squared minus 14x equals, and this is 32. 2 to the 5th power is 32. Well, this is a quadratic now. So the way we solve a quadratic is we set one side equal to 0. So we're going to subtract 32 from both sides, and we get x squared minus 14x, hang on, it's ugly, minus 14x minus 32 equals 0. This quadratic is factorable. There are two numbers that multiply to negative 32 and add up to negative 14. They are negative 16 and 2. So we're going to have x minus 16 times x plus 2 equals 0. Okay? And then we're going to set each one of these equal to 0. So we're going to have x minus 16 equals 0. And we're going to have x plus 2 equals 0. Add 16 to both sides, and we get x is equal to 16. Subtract 2 on this one from both sides, and we get x is equal to negative 2. And so these would be the solutions, two solutions. However, we have a problem with this solution. This x minus 2 cannot be a solution. In fact, I'm going to write that right now. I'm going to say this is not a solution. Okay? Why? Well, look at this. X is negative 2. If we plug that in up here for x, we would have log base 2 of negative 2. And we said in one of the previous lessons that you cannot take the logarithm of a negative number. You can't take the logarithm of a negative number, and therefore negative 2 cannot be a solution, and the only solution therefore is x equals 16. So the final answer is simply just x equals 16. We're going to do one more example. Okay, this one is very similar to the last one. You can see we have the natural log, two natural logs, and they're being added together, so we can use the property of logarithms. We would do a single logarithm, natural log, and then multiply the x times the x minus 3. So natural log of x times x minus 3 by the properties of logarithms equals 2. Now we make each one of these sides, now it looks like this form, so we make each side of this an exponent with a base of e, because the base of natural log is e. So we'll have e to the power of natural log of, I'm going to distribute this x, so I get x squared. X times negative 3 is minus 3x equals e to the second power. Now, this e to the second power is not easy to, so last time we had 2 to the 5th power, and that we just made it a 32. This e to the second power is a little crazy. We're better off just leaving it as e to the second power. Over here, we're going to cancel the e to the natural log. We're going to bring down x squared minus 3x equals e to the second power. Now we're going to subtract e to the second power from both sides because it's a quadratic. And so we're now going to have x squared minus 3x minus e squared equals 0. Remember this e squared, that's a number because e is a number. So e squared is also a number. Okay? So now we can't factor this because this does not play into the factoring. Okay? So we're going to have to use a different method. We're going to use the quadratic formula. Okay? So here we're going to say that a is equal to 1 because the coefficient of x squared is 1. B is equal to negative 3. and then c is equal to negative e squared, which is a little weird, but we can do it, okay? So now our quadratic formula is going to go like this. X is equal to negative b, negative 3, plus or minus the square root of b squared, that's negative 3 squared, minus 4 times a, which is 1, times c, which is negative e squared, all over 2a. That's 2 times 1, okay? So let's clean this up a little bit. We get x is equal to negative 3 is just 3, plus or minus, oops, 3, plus or minus. So square root of, well, negative 3 squared, that's 9. Now, negative 4 times 1 is negative 4. And then negative 4 times negative e squared, we have a negative times a negative. That's a positive. So we have positive 4 times e squared, which is just plus 4e squared. Okay? All over 2 times 1 is just 2. So this is our x. Okay? So now, what's really funny is that this can't be simplified. 9 plus 4e squared, that's as simplified as it's going to be. So really, all we have to do now is plug this into a calculator. Okay? I'm going to go all the way over here. So one of our solutions, remember, we have plus or minus, so we have to do 2 solutions. So one of our solutions is going to be 3 plus the square root of 9 plus 4e squared over 2. Let's go into the calculator and do that. So we're going to do 3 divided by 2. That'll give me my fraction. Now in the numerator, I need to do plus the square root of 9 plus 4e squared. There we go. This is the whole thing. Now I just press execute, and I get 4.605. So this is going to be 4.605. Our other solution is going to be x is equal to 3 minus the square root of 9 plus 4e squared all over 2. And let's put this into the calculator. Now I have good news for you. This calculator will actually allow you to grab the last question. And now we can just go into it, and we can just change this into a minus and get rid of the plus. There we go. So now we have 3 minus. All the same thing. Execute, and we get negative 1.605. Negative 1.605. And we're just about done, but we have a problem again. Look at this negative 1.605. Look, we cannot put a negative in for x because we can't take the natural log of a negative number. We cannot do the natural log of negative 1.605. We cannot do that. Therefore, this solution, this negative 1.605, is not a solution. And therefore, our only solution is x equals 4.605. Okay? That's it. That's how we solve logarithmic equations. And I think, we did about 7 examples here. That should be enough practice for you to be able to try out some homework questions.